Hi everyone, in this PreLab video, I'm going to go over this topic for the making ester lab. Ester are organic molecules that are responsible for flavor in fruits and also floral aromas, as you see some of these here. Ester are often prepared from the reaction between carboxylic acid and alcohol, which also are organic molecules. Organic molecule mainly composed of hydrocarbon, which contain hydrogen and carbon, and there will be small part of the molecule that contain other functional groups. And these functional groups right here would be the one that would alter the property of the molecules. These are the list of the functional group that you will learn in class. In this lab, we are going to focus our attention on ester. Esters are the organic molecule that contain these C-double-bond-O that attach to the hydrocarbon on each of these sites. Okay, so pretty much if you looking at the general formula right here, right, so those are going to represent the hydrocarbon. So this hydrocarbon can be any number of the carbon, okay, that attach to the hydrogen. Another two groups that you will encounter in the lab are carboxylic acid and alcohols. These two are going to be used to prepare ester. Okay, so alcohol would be the hydrocarbon that attached to the OH group. Okay, so that's OH group right there. So again, the R can be any hydrocarbon, right? So the number of carbon can be various. And carboxylic acid are the organic molecule that contain this group, C-double-bond-OH, okay, so that attached to the hydrocarbon. And again, this R right here is going to represent the hydrocarbon. The process of making ester is called esterification. It's going to involve with the reaction between carboxylic acid and alcohol. This reaction is going to involve with the condensation of water because this OH group is going to react with this hydrogen right here. And at the end, you are going to end up with water. The remaining part would then combine with each other to produce ester. In this lab, we are going to use sulfuric acid to speed up the esterification. Note that in this process right here, you are going to form water that is also can hydrolyze the ester that is going to go into the reverse direction. So that means the more water that present in the reaction is going to cause reaction to go in the reverse direction. So you are going to end up with the lower yield of ester. So in order to avoid that, the sulfuric acid that we are going to use is have to be in the concentrated form. Okay, so that means you are going to need to perform your experiment in the film hood to avoid the inhalation of the sulfuric acid. Next, I'm going to talk about the PreLab assignment. Number 2, it asks you to find out the functional group for each of these molecules. So before we do that, just note that in lecture, you will learn about all of these functional groups and also how to recognize them. Okay, now I'm going to walk you through this real quick. Okay, so what you are going to look at is you are going to look at the hydrocarbon first. Okay, so these two are what we call hydrocarbon. So this is not hydrocarbon, right? So it's not only carbon and hydrogen. So this is what we call functional group. Okay, so carbon double bond to the oxygen. This is a functional group. This functional group is what we call ketone. Okay, so this is ketone. Next, when you see hydrocarbon is right there, everything else that doesn't contain carbon and hydrogen, so those are going to be the functional group. Okay, so that is functional group. This functional group contains carbon double bond to oxygen, and the other side is OH. Okay, so this is what we call carboxylic acid. The reason why it is an acid, you see some of this before when we talk about the acid in chapter 14, right? Because the bond between oxygen and hydrogen here is very polarized, making this bond is weak, right? So therefore, in this case, this molecule is going to be able to give off proton very easily. So that's why this molecule is an acid, right? So this is what we call carboxylic acid. Next one for C, okay, so where are the hydrocarbon? Well, it's right here and right here, right? So that means the rest of that would be the functional group. Okay, so this is going to be a functional group. The functional group that contains carbon double bond to oxygen, right, and attached to oxygen, but the other side of oxygen is not hydrogen, right? So you replace the hydrogen with another hydrocarbon. This right here is what we refer as ester. Next one, okay, so the one that is hydrocarbon would be that part, right? So everything else is going to be the functional group. This functional group contains carbon double bond to oxygen, and the other side is just the hydrogen. So this is an aldehyde. Next one, okay, so we have hydrocarbon here, so therefore that is going to be the functional group. So this functional group is what we call alcohol. And then same thing here, right? So that's hydrocarbon, that's also hydrocarbon. So functional group would be that one right there. So this is an amine. Okay, so next we have hydrocarbon, and we have just oxygen in the middle between the two hydrocarbons. So this is an ether. Next, we are going to learn how to predict the product for an esterification reaction. Okay, so between carboxylic acid, which is acetic acid, and alcohol, which is ethanol. Okay, so if you're looking at these two molecules, okay, so these are the functional group, right? So these are the functional group that are not hydrocarbon. Okay, so this functional group right here, okay, so double bond O, right, and OH, this is carboxylic acid. Okay, so OH, that is alcohol. according to the esterification reaction that you see in the previous slide, right? So the OH group from carboxylic acid would then react with the hydrogen from an alcohol to form water. And the remaining of these two parts would then combine. Okay, so what I'm going to do is that I'm going to write out the remaining of this part first. Okay, so C double bond oxygen to CH3. Okay, so it's that part right there. And the other part, okay, so the remaining would be this part right here, right? Oxygen, CH2, and CH3. So what I'm going to do is I'm going to connect that, right? So oxygen, CH2, and CH3, you are going to connect these two together. And that's it, right? So again, carboxylic acid react with alcohol. It's going to form ester and water. Now let's take a look at the overview of the procedure real quick. Okay, so in part A, you are going to make 3 esters. Okay, so the first one in test tube A, you are going to add the alcohol methanol and react it with salicylic acid, which is the carboxylic acid. Okay, so you are going to add the sulfuric acid as a catalyst. You will make each of these test tubes one at a time, okay, because you are going to do this in the film hood, because the sulfuric acid that we are using is going to be the concentrated sulfuric acid. Okay, so I don't want you to inhale that. So for the second test tube, this is going to be the reaction between the alcohol pentanol. The carboxylic acid that we are using is ethanoic acid. Okay, so again, you are going to add sulfuric acid as a catalyst. And the last one is going to be octanol that react with ethanoic acid. Okay, and then you are going to add sulfuric acid as it. Once you finish each of these test tubes, you are going to put it in a hot bath. Okay, so don't forget to put the glass door rod in it. You are going to mix and then boil this mix. You are going to boil this mixture until you observe a significant change. Okay, so for example, you might see color change or you might smell something. Note that the hot bath in the film hood can be shared, and you will need to replenish the beaker as water vaporizes as well. And also make sure that the electrical cord is away from the heat source. Okay, so that way it doesn't melt the electrical cord. Don't forget to record the observation, and also you will need to make sure you record the odor of the alcohol before the reaction as well. So as you add alcohol in the reaction, right, so smell that, right, before you add any other substance in it. After the reaction, you will also need to make observation of the odor of the ester as well. Part B, you are going to use the model kit to construct the organic molecule. The organic molecule that you will construct would contain these functional groups and also just an alkane and alkene as well. Your lab instructor will go over what are the alkane and what are the alkene. For the data collection in this part, you are going to draw a ball and stick molecule. Okay, so for example, if you have water and chloroform, right, so these are going to represent Lewis structure, and these are going to represent the ball and stick model. Okay, so just draw this one into your lab notebook. For the result of part A, you are going to learn how to draw line structures and also how to predict the product that come from the reaction between carboxylic acid and alcohol that you did in part A, right, from those 3 test tubes. Okay, so let's take a look at what is line structure. Okay, so in Chem 121, you learn about Lewis structure already. Okay, so Lewis structure tells us about the connectivity of each atom right within a molecule. If you look at this molecule right here, this structure is seemed to be very complex. So the line structure is used to simplify this. In line structure, we are going to only represent carbon and only functional group. The reason for that is because the functional group will be the only part that will participate in chemical reaction. You will also learn about the condensed formula in class also, but the line structure would be the one that we will use in the result table. Okay, so for example, okay, so I'm going to walk you through how to write the line structure for esterification between salicylic acid and octanol. You did not do these 2 molecules in the lab, but I'm just going to give this as an example. Okay, so pretty much the process will still be the same for your test tube A, B, and C. Okay, so just different alcohol and different carboxylic acid. For line structure, you are going to omit hydrogen. You are going to show only the connection between carbon and carbon and also the functional group. So I'm going to start with salicylic acid. Okay, so this one right here, you probably notice that it contains 6-membered ring. Okay, so I'm going to start with that. Okay, so each of these ring, okay, so at each of these corner are going to represent carbon. Okay, so we have 1 carbon, that one right there, connected to another carbon, which is that one right there, connected to another carbon, which is that one right there, and so on. Okay, so you probably noticed as well that between these 2 carbon contain double bond. Okay, so that double bond right there, so that means I need to add that. Okay, so next, these 2 carbon also contain double bond. So I'm going to continue doing that as well. And the last one is right there. Okay, so again, I'm going to omit hydrogen, okay, because hydrogen will not participate in chemical reaction in this case. Okay, so the next one, you probably notice that this carbon contain OH group. So I'm going to go ahead, right? So write out an OH group. Okay, so that alcohol group right there. And next, this carbon right here connected to another carbon, which is part of the functional group. So what I'm going to do is that I'm going to make this bond between these two carbon first. Okay, so those are that one carbon and that's the next one, right? So this is the one that contains functional group, right? And then this carbon contain double bond oxygen, right? So that parenthesis right there indicate that this oxygen is separate from OH, right? So it's attached directly to carbon. So that is going to be the double bond. Okay, so I'm going to do double bond oxygen. And the last one, this carbon is going to attach to that last OH. This is the carboxylic acid functional group that we learned before. Okay, so this is going to be the one that will participate in chemical reaction because we need carboxylic acid to react with the alcohol. That means the alcohol functional group that present in salicylic acid will not participate in chemical reaction in this case. Okay, so next one for octanol. Okay, so octanol, the word octa comes from the fact that it contains 8 carbon. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and all come from the fact that it contains alcohol, right, which indicates that this molecule is an alcohol. In order to draw line structure of octanol, you are going to connect each of these carbon, right, and you are going to omit hydrogen, and last one you need to show the functional group OH. So I'm going to react this salicylic acid, okay, so with octanol. Okay, so I'm going to start with this carbon first. So this dot right here is going to represent this carbon right here. Okay, so I'm going to connect this carbon to the next carbon. Okay, so again we are going to omit hydrogen in line structure, and the end of this line are going to represent carbon and carbon. Okay, so I'm going to connect this carbon with the next now. So I'm going to make it zigzag because each of these carbon in reality, they are going to exhibit tetrahedral. Okay, so if you make a straight line, that is not going to represent tetrahedral. Okay, so the next one is going to be the fourth one, right? So I'm going to make the connection between the third and the fourth, and then the fourth to the fifth, and the fifth to the sixth to the seventh. Okay, so 7 to 8. Okay, so now we are at carbon number 8. Okay, so carbon number 8 connected to OH functional group, which is the alcohol functional group. So I'm going to make another bond between carbon and oxygen and hydrogen. So that would be the functional group right there. So what I'm going to do next is that I'm going to flip this molecule. Okay, so I'm going to just flip it. Okay, so if I flip it, it's going to look like this, right? So these two are identical. You might ask me, why do you flip it? Well, the reason why I flip it because eventually I will need to merge this molecule, right, together with that carboxylic acid molecule, right, because we are going to form an ester. In this case, what you are going to do is that you are going to remove the OH from carboxylic acid and remove the hydrogen from an alcohol and condense it out as water. And therefore the remaining, okay, so the remaining would be this part, right? So that remaining right there is going to combine with the remaining of the alcohol as well. Okay, so that's going to be the remaining part. So therefore, in this case, you are going to get this ester as your product and water. Again, for part A, you will use the concept of line structure that I just went over to apply for these carboxylic acid and alcohol. For the supplementary question, please note that you are going to learn how to name these organic molecule in class. Okay, so once you learn in class, you should be able to complete this part.